So let's revise sketching trig graphs. We'll do a bit of logs, hopefully. We've got a time and then a bit of calculus as well. All right, trig graphs. You've got, I guess, you've got a few of them, but the big three you need to memorize is sine theta, cos theta, and tan theta or tan x. Once you've memorized it, everything else, all the shifts, the ups and downs and left and rights, it works exactly the same as your parabolas. So first thing you need to do is memorize your original graphs. That's 2 pi, that's pi, that's 1, that's minus 1. You need to know your amplitude equals to 1. So your amplitude is the number in front, A. And then you need to know your period, which is 2 pi on n, where n is this number here. So n is the number in front of your x, which in your normal sine x curve, it will just be 2 pi. The way we interpret this period is we see 1 sine, which looks like this. That's 1 sine every this time. Every, for example, 2 pi times. Well, that's the way you have to interpret this. If you said pi, I would say I'd see 1 sine every pi. All right, cos, same thing. You've got to memorize the graph. Amplitude and period stays the same. Period is 2 pi on n. Just you got to know the graph. And then tan. 1 tan actually looks like this. That's 1 tan. And then you got to continue this pattern wherever you are. Your period for tan is not 2 pi, it's pi on n. So in this case, it's every pi. And tan doesn't have amplitude, right? Tan goes on forever, up there. So your y values go on. Okay, any questions about this? So once you've understood that, and you understand your period and amplitude, then, for example, I might give you a question like a sketch. You got to first, like I said, you got to memorize each of these, right? So assuming these have been memorized, sketch y equals, let's call it 3 sine 2x. Might look hard, but if you follow the rules I've just said, they're pretty straightforward. Your amplitude is equal to 3, right? So you're like, all right, I know that goes to 3 and minus 3. My period is the second thing you need, which is 2 pi on n, where n is 2. So that's pi. So how do we interpret this again? I see 1 sine every pi. Right? See 1 sine every pi. What does 1 sine look like? 1 sine looks like this. Don't forget that. That's shape. So if I see 1 sine every pi, that means it'll look like this. That's only pi. But generally, they're going to tell you to sketch from to 2 pi, let's say. So therefore, you're going to see two sines up to 2 pi. And then, I mean, if they gave you a different domain, they said, hey, draw it from like negative pi, I don't know, to pi. Then, you know, you would have continued this. There's negative pi, and then that's negative pi to pi for that one there. Have I lost anyone? Or does anyone not get this? Or does someone, or the opposite? Does someone go, yeah, I actually fully get this? No.
Yeah, it makes sense.
So you get it from the way I've said it. Amplitude, go up 3, go down 3. Your period, if you've got pi, it means you see one sine every pi, assuming you've memorized the shape of your sine, cos, and tan. Really, then you're just drawing, and then it just tells you where to start and stop. You don't look at the domain, you just draw however many you want, and then you can just start and stop it as you wish. It's the better way. Yep. So let's do a few more, I guess, just to make sure. And then we're done. I don't know, there's nothing else to do there. Oh, that hasn't been shifted, right? But if you need shifts, you'll know that you're going to say pluses and minuses. So let's do y equals cos, I don't know, 4x. Let's draw this one. Your amplitude is 1. Your period is 2 pi on 4, which is pi on 2. And what do you guys want my domain to be? You tell me where to draw it from. Someone. Doesn't matter.
0 to 2 pi.
Okay, so your normal ones. So 0, 99.99% of the questions are 0 to 2 pi. 0 to 2 pi. All right, here we go. So, I know that I see one cos every pi on 2. I've memorized my cos. I know that shape is that. So here we go. And I know my period. I know my amplitude. That's pi on 2. That's pi. I'm going to run out, aren't I? That's half a pi, 1 pi, 1.5 pies. So 3 pi on 2. And 2 pi. Does that make sense?
Don't you have to like put it in a calculator and put points and like trace it?
No. If you know what you do, if you're doing a profession like me, no, not really. No. You can. Look, your table of values will never fail you, so you can do that. It's just slower. But this is obviously the professional way of doing it. Like, you want to learn how to do it properly, that's the way it's done. Anyone else? That's another one. I mean, do you have any questions you want me to try? Does anyone have any questions that they've done at school you want us to do together?
Can we just practice phase shifts?
Say that again, shifts?
Yeah.
Yep. So if I had to shift this, I'll just so you know, if I had to shift this up 5, but wait, I don't know, I think that's year 12. Have you done shifts up and down and left and right? Because I think that's part of year 12.
Yeah, we've done that like 2 lessons ago.
Plussing 5?
Yeah, like vertical and phase shifts.
Yeah, fair enough. It's part of year 12, but I think some teachers are just bringing that in year 11 to start you off. That's okay. Cos 4x plus 5. It's not that it's any harder, so don't worry. I just do a bit differently to, again, your textbooks. What I would tell you is, instead of, and once I do what I'm going to say, you guys are going to be like, but of course, why don't they just do that? Instead of me, traditionally, you guys would have shifted up your parabola up 5. Right, there it is. It's easy, it's not a problem. But like, what a mission it's going to be to move this whole thing up 5. Like, that's just annoying, right? It really is. So the way we do it, instead of moving up the graph 5, so let me show you. I'll redraw it very carefully. I'm going to redraw it. 1, 2, 3, 4. Okay, that's 2 pi. That's pi onto, that's pi, that's 3 pi onto, okay, all right, perfect. Okay, right, we've got this graph. Instead of moving this whole thing up 5, can you guys see I can actually shift my axis down 5? Right, that makes sense, doesn't it? So instead of shifting this whole graph up 5, wouldn't it be the same as me shifting my axis down 5? Does that logic make sense to you guys?
Yeah.
Yeah. So that's the way you're going to see me do it when we're doing it, especially more in Year 12. So that's going to be a minus 5. Right? Sorry. That occurs where it was minus 5. That's your new 0. That's going to be at 4. That's going to be at 5. That's going to be at 6. You're adding 5. So you move your axis down 5, and look what happens. Look what it looks like. It looks like all of a sudden my graph just got shifted up 5, doesn't it? Because that's at 5 now. That's at 4. That's at 6. Does that make sense?
Isn't that the same as just moving the graph?
Yeah, but it wasn't a lot easier to, like, okay, if you think so. Maybe you haven't done hard questions yet.
No, I guess I just think of it like that, but I don't know.
Yeah, it is. Well, yeah, it's meant to be the exact same. The difference is instead of me moving this up and down, this whole graph in midair, and knowing that it has to go 6, 5, 4, and so on, it's just a lot easier to move this graph down. And I'm talking about on the same graph, like you don't even draw a new one. So all you would do, you would keep, if this was done in pen, you'll just keep it there. There's no problems with it. As long as you're writing that's 0. So there's no need to shift anything. It's just super quick, efficient, it's cleaner. There's less room for mistakes. It's not so much these ones that are my worry, but it's these ones that are my worry. Let's say the exact question where I went 4x plus 10 and then plus 5, that you definitely won't get right. And then if I also gave you the original and I changed the domain from, like, I don't know, negative pi to pi, you're going to also struggle with that if you're just going to try to do it the moving. So anyways, that's just my take on it. But yeah, it has to be the same as moving the whole graph. It's just instead of moving the whole graph, I'm avoiding that by moving the axis instead. Let's do another one. You guys start to realize my methods are very different to your textbooks because I don't follow any textbooks. Y equals, whereas your teachers all do. Y equals, let's think of one. Let's think of one. Sine x plus pi. Okay, my amplitude is still 1. My period is still 2 pi because on n is 1. It's in front of the x, which is still 2 pi. So I now know my sine graph occurs every 2 pi, which is that, right? Now, Giovanni, watch this. So you got to draw this graph from this to this. Now, what you will see me, or you're obviously watching me do this right now, you're going to see me always tell you if you're going to have left and right movements, draw more. It's better than drawing less because you're about to move this thing. You might miss a few things. So let's say we've got that one there, and that's at pi, 2 pi, that's 3 pi. Let's say we've got that last one, 4 pi. And if you want more, why not do some more here on the left? Okay, there, you got everything now. Right? Now we've got to move this whole graph to the left pi degrees. To me, instead of moving this whole graph and redrawing it somewhere down here and doing the whole all over again, what I do is instead of moving my graph to the left pi, I move my axis to the right pi. So that's where my new 0 is. And then that would not be 2 pi anymore. That would now just be pi. That would not be 3 pi. That would be 2 pi. Right? Because you moved the pi degree. So everything gets shifted. And that becomes 3 pi and so on. So the answer to this question is this. So yeah, you'll get the hang of the movements of axes if you practice it a fair bit. It's just easier to do that than it is to move the whole thing. That's it. Otherwise, if you had moved it, this bit here would have moved up here. And this line here would have come here and so on. Okay. Should we do another one, or is that making sense? You just need to go and practice it, maybe.
Can you do 10?
10? Just normal 10?
Like hard version of 10.
Hard version of 10. Hard version of 10. Yeah, period. Okay, X on 4. I guess. That's hard. So amplitude doesn't matter. Period is pi on n. What is n equal to? What's the number that's multiplied by x?
One.
1 over 4, a quarter. So that means 10 occurs 1/10 every 4 pi. Remember, 1/10 looks like this. Right? Sorry. For example, 1/10 usually looks like this. But saying now you're going to see one of these every 4 pi. So again, you're going to draw it. Right? You just draw it normally. There's 1/10. But it occurs every 4 pi. So that's 4 pi, which means what's your asymptote now? Halfway, right? 2 pi. So if the question said draw the graph from 0 to 2 pi, your answer is just this. That's it. Whereas everyone thinks, oh, what? But that doesn't look like a tan. That looks like an exponential or whatever. Well, too bad. That's what happens because of your domain and your period. So, I guess you could say that's a hard 10. Yeah. All right. Let's do a bit of log revision now. So, your log laws. Log x, y, when they're multiplied, you can add your logs. Log x on y, when they're divided, you can subtract your logs. And then log x to the power, you're allowed to bring your power down as long as it's logged. Don't forget that, and then, yep. So this one, evaluate the following expressions. See, they're the same subbases. They're both monic. So I can just write log 25 times 4, which is 100. and then sub base 10, and that becomes log 100 on log 10. And then if you plug that into your calculator, I'm sure it'll give you 10. And this one, log 40 over 5, and then that's a 2. Log 8 over log 2, that should get you 3. Did I say 10 here? Should have been 2. Any questions there? Because it seems like that's where you guys are going wrong. You get that now? Any questions? Okay. Well then let's have a look at D. 2 log 3 sub base 6 plus a half log 16 sub base 6. Okay. You can't have the 2 and a half there, right? So we'll do exactly what we did before. 3 squared, that's 9. 16 to the power of a half is 4. I end up with this. Do we understand that line there? And then, same sub bases. 9 times 4 is 36. ln 36 on ln 6. That should also get you 2. Any questions there? Okay, let's see what we can do with these ones. All right, what's your first step? You guys understand what I've done there? Remember, they've got to be mnemonic. I can't have numbers in front of them if I want to use my log laws. Then 3 times 4 is 12, 2 times 5 is 10. What do I do now? I've got a log of something,
Divide.
x of 12 over, yeah. And that just cancels out. You've got 2. You can have log x squared. If you really wanted to, you can bring the 2 down. It doesn't really matter by that stage. Either one is fine. Let's do it again. What are you going to do with the 3? Or bring it up. A to the power of 24 over log. Remember, that's a to the half. Then you're going to times that by 4 as well, because you're going to bring the 4 up. A squared. Okay, this one, don't say you can subtract, because it's a log over a log, right? You can only subtract if it's a log of a term divided by a term, not a log divided by a log. So what you're going to do to simplify this, you're actually going to bring the powers down. 24 log A on 2 log A. Your log A's cancel. 24 divided by 2 is 12. Any questions? Rewrite without logs. Okay, what would you do with this one? Rewrite without logs. What's the first thing you can think of? Go.
Bring the power up.
So you would write log 3y squared minus log 3x cubed equals 2. Now, they're monic, which is great, but they also have the same subbases. Because they have the same subbases, you can just combine them. So you can go log y squared on x cubed with a little 3 if you wanted to. Whereas me personally, what I would have done is just done ln's. Just because I know what, I don't like subbases, but we'll leave it for the time being. Then the next line, you're obviously going to change your subbases. Excuse me, sorry. And then you're going to multiply your log 3 over almost there. Why am I doing all this? Because it says write it without logs. That means the logs need to somehow cancel out eventually. Please don't cross out the logs. That would be completely wrong. You don't cross out sign. You can't cross out logs later. You're going to do the opposite. If you're wondering why I crossed out here, is because it says log A on log A. So I'm crossing out a whole number over a number. You can't cross out ln with ln. That doesn't ever work out. 2 goes on the top. And now you exponential, and these will cancel out. So you just got y squared on x cubed equals 9. There you go. You're able to write it out without any logs. Yep. See, let's start from the beginning. I brought the power up, then I combined them using the fact that logs are subtracted, you can divide. Change of base, multiplied it, and start solving. Let's do it again. So like this one here, just so you guys know, see, you can't write, I don't know, log 949 on 7. Doesn't work because that's a 9, that's a 3. Because it's doing that, what you've got to do is go log 49. Because it's already monic, which is great. Log 49 on log 9 minus log 7 on log 3. And then log 49 and log 9. Okay, so how is this linked with 7 and 3? Well, log 49 is log 7 squared, log 3 squared. And then what do you do with your 2's? 2 comes down. 2 comes down. Your 2's will cancel out. And then what's log 7 on 3? Log 3 minus log 7 on log 3? Any questions there? Alright, let's do one last equation. Let's do an exponential equation. Let's do this one here. Okay. Alright, so when we're trying to solve, so you're trying to solve for these now. So you're not simplifying like the other ones up there. You're solving. So you're going to solve for x, which means x is on one side. So what I'm going to do is I'm going to bring this, leave this one here. So that becomes log x to the power of 5 on log 10. This 3 goes on the top. and then I'm going to subtract it. So it's going to look like this. Log x cubed on log 10 equals, and then bring the minus 8 to the other side, which is equal to 8. I'll pause there. Anyone, was that too fast? Bring the 3 up as a power. That becomes x cubed. And then I'm also going to subtract it, which will look like this. And then the minus 8, bring it over to the right hand side. Any questions? At this stage, I would, you've got a common denominator of log 10, so you're probably going to multiply this side by log 10. So you really only have this on the left-hand side, and this one would be 8 log 10. What do we do when we subtract logs? And then you cross out your logs. X squared equals 10 to the 8. It means x equals 1,000, 10,000. Why did I do plus minus? Because x has to be greater than 0 for logs, right? You got an asymptote at x equals 0. It doesn't work. So I didn't bother writing plus minus for those who are thinking. It's just 10,000. Any questions there?